All right, Unit 4. So we're going to talk about proportional relationships. You've studied proportional relationships in previous courses, but they are all the basis of all linear functions. So we will take a lesson to recall the particulars. So two variables have a proportional relationship if their respective values are always in the same ratio. They have the same relative size to one another. In equation form, if the two variables are x and y, then y over x equals the constant. So let's look at exercise 1. At a local farm stand, 6 apples can be bought for $4. Determine how much it would cost to buy the following amounts of apples, round to the nearest cent when necessary. So we know that for $4 you can buy, $4 you can buy 6 apples. And we want to know how much would it cost if you have 12 apples. So what you do is you actually are going to cross multiply. So we have 4 times 12 equals 6 times x. So 4 times 12 equals 6x. And then 4 times 12 is 48 equals 6x. Divide both sides by 6. So it costs $8. So what about 20? So again, $4 over 6 apples is how much for 20 apples? So again, we're going to cross multiply. So 4 times 20 equals 6x, which 80 equals 6x. Sorry, 80 equals 6x. Divide each side by 6. And x equals, if you were to do this in the calculator, it's 13.33 repeated. So for money, that's $13.33. So now if C is the total cost of apples and N is the number of apples bought, write a proportional relationship between C and N. Solve this for the variable C. So we know that it's $4 for every 6 apples. And this equals the cost over the number of apples. But it says that it wants you to solve for the variable C. So you want it to be a C equals. So we need to get C alone. So what we have to do is we need to multiply both sides by n. The reason why we multiplied both sides by n is so that we cancel out this divided by n over here. So C equals 4 over 6n, but this can be reduced, so C equals 2/3 n. Now, looking at letter D, it says graph the relationship below. So we look at number of apples below and the total cost. You notice that it goes up by ones and over by ones. So every every 6 apples is $4. So you could go up proportionally. I go up 4 more, 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6. You'll also notice that it's the same thing as going up 2 over 3, up 2 over 3, up 2 over 3, and so on. So our constant rate is the same. So according to the graph, C of 15 equals 10. So this is using the information that we learned last unit with functions. So C of 15 equals 10. So C of n equals 10. So how do you interpret this in terms of apple and money? Well, this is saying if 15 is our n, so 15 apples costs $10. Exercise 2. If Jenny can run 5 meters in 2 seconds, then which of the following gives the distance, d, she can run over a span of t seconds going at the same constant rate? So we know that she can go 5 meters every 2 seconds, and this is our distance over time. But we want to know what does D equal? So I need to multiply by T on each side so that I just have D left. And 5 halves T equals D. So the one that represents that is number 4. Exercise number 2 illustrates one of the most important proportional relationships, that of distance traveled compared to time traveled at a constant rate. Let's work some more with this. So Erica is driving at a constant rate. She travels 120 miles in the span of 2 hours. So we know that she travels 120 miles for every 2 hours. So her rate is 120 over 2, but we want to know what's her total distance for 3 hours. So we can do cross multiplying. So 3 times 120 equals 2 times D. So 360 equals 2 times D. Divide each side by 2, and her distance is 180 miles. So write a proportional relationship between the distance D that Erica will drive over the time T that she travels, assuming she continues at the same rate. So again, 120 over 2 equals a total distance over time. But we want to solve for just D, so just the distance. So we multiply both sides by T. And now we have 120 divided by 2 times T equals D. This can be reduced because 120 divided by 2 is 60. So 60 times time equals the distance. So what is the value of this proportionality constant? What are its units? Well, it's 60 miles per hour. It's their speed, how fast that they are traveling. So how much time will it take for Erica to travel 150 miles? Well, if distance equals 60 times time, we can plug 150 in for the distance, solve for T by dividing by 60, and the time is 2.5 hours. Now letter E says graph D is a function of T on the axis at the right. What you can do is you can make a table if you wanted to, where we have our time and distance. So at 0, they've gone 0 miles. At 1 hour, they've gone 60 miles. At 2 hours, 120. At 3 hours, 180. And then you can plot those points. So 0, 0. At 1, they're at 60. This is going up by 20s. So 20, 40, 60. And then 2 is at 120, so right here. And then at 3 is 180. So there is your constant speed. So what does the constant of proportionality from C represent about the graph? Well, obviously it's the slope. It's the slope, which is rise over run.